My name is Gabriel. I'm the founder of Aries Market. Today I will be presenting building a boring lending protocol on Sui. And specifically, we built several lending protocols on other blockchains and how is our experience using Sui Move and how it enabled us to build extensive and also flexible protocols. Here's a brief agenda of today's presentation. I'll provide a brief intro to Sui and Sui Move language, some of the abstractions, and also I'll provide an intro to the protocol that we are building, what are some of the unique features that we provide using Sui Move. And then I'll provide an architecture overview, what are some of the abstractions that we have used, and how this abstraction make the protocol better. And I'll provide some concrete examples on Sui Move and how do we utilize some of the language features to enable us to build this protocol. And towards the end, I will provide a demo and then some further implementation that we can do. First, programming on Sui. On Sui Move, everything is an object. So the contract that we have written is an object. The coins that you have in your wallet is an object. And then all the smart contract that we implement is also using the object model. And then within the object, there's difference between shared object and owned object. And Sui is quite unique in the sense that for own object, it doesn't require consensus. If a transaction that only touches an own object, it doesn't require consensus. It only needs to respect the causal order of the blockchain. But one issue that we encounter during our implementation is that we need to explicitly pass in all the objects that the transaction touches. This actually makes the development life slightly harder because we need to specify all of the data that we want to touch beforehand instead of the runtime automatically detects it. But it kind of works similar in a sense for like Solana, where you need to explicitly pass in all of the accounts. Now, here's the protocol that we are working on. So a boring lending protocol using peer-to-pool model. It works kind of similar to Aave and Compound, where users deposit into the pool and borrow from the pool. And it also supports cross-margin. So all of the assets that get deposited into the pools will be calculated in dollar values together. And similarly for loans as well, all of your borrow positions will be calculated together. One thing that's unique about our platforms is that we support sub-account. So for users who are risk averse, they can create multiple sub-accounts. And for one account, they can use it as their savings account, and that would not be subject to liquidation risk. And for other accounts, they can use it as degen tradings. And even if one of these sub-accounts gets liquidated, it won't affect your other accounts. And additionally, we support dynamic interest rate. So dynamic interest rate in the sense that the interest rate curve can be changed whatever you want. You can define whatever curvature that you want. This is quite unique compared to other lending protocol where you can only change the parameter of interest rate curve, but not the actual curvature. And finally, we support asset agnostic flash loan. So asset agnostic flash loan, so that when you take a flash loan from the protocol, you borrow one asset and you can actually repay a different asset. So that's quite useful when you do arbitrage. And technically, it will allow us to use flash loan to liquidate all of the bad debts. Now let's take a look at the overall architecture of the protocols. So we have three abstractions, lending market, reserve, and also profiles. So lending market sits at the very tops, and reserve is for each tokens that we support. For example, if we support USDC, then there's a USDC reserve. If we support Sui, then there's a Sui reserve. And if we support Bitcoin, there's a Bitcoin reserve. All of the reserve under one lending market will be calculated together when we do the cross-margining. And then every user will have a profile, and this profile corresponds to one user's sub-account. So for one account, they could have multiple profiles. And for lending market, reserve, and profiles, everything is an object, and specifically, everything is a shared object. So you might be wondering, why do we need to have a profile to also be a shared object? It seems like making more sense if it's an own object where only the owner of the profiles gets to deposit or borrow from their own account. The main reason being that we need to allow permissionless liquidations, where anyone on the network could come and liquidate bad debt. When the profile is underwater, then you will want anyone to come in and liquidate it. And that means we will need to make the profiles to be a shared object instead of an own object, where it requires the owner's signature. So now let's take a look at some concrete examples on how we utilize Sweetmove. I will share with you some code. So first, we support, so here's a definition of lending market. So the highest abstraction in here. And then for lending market, it contains several data structures, including reserve status, which records how much liquidity we have in the lending protocol, how much have been borrowed out, and how much is still remaining, and its fee. And reserve config, which records all of the risk-related parameters, including like loan-to-value ratios, and then maximum borrow, maximum deposit. And reserve oracles defines how do we read actual price data from outside world. And interest config define the unique customizable interest rate curve that I mentioned earlier. And for reserve, we define a move struct called reserve, and this move struct records token balance and how much fee it has generated. So if you remember, we have all these three abstractions. You might be wondering why we need to store all of this information, reserve status, reserve config, in the lending market scope, but not store it in here in the reserve scope. So this is because the reserve is polymorphic. It's different based on the type of coins that we support. In order to allow for dynamic looping through every reserve that the user have, we will need to make it in a standard place, which is in the lending market, where all of the data can be accessed by just passing in one object instead of several reserve and if we actually want to pass several reserve, it would just make things a lot more complex. And also, it's super important to have access control. Why is it important? So suppose that you have a lending market, then you don't want anyone to come out and create a shit coins and add those shit coins to as collaterals. And then what they can do is they put in all of the shit coins and then borrow the legit coins. So that's why it's super important to have access control. So we use capability for access control. First, we have the admin capability, which corresponds to the privilege to create new lending market. And we also have a market capability, which corresponds to the privilege of adding new reserves, so adding new assets that get supported in the market. And that corresponds to a specific market address. And also, we have multiple profile support. So that's for each user, you could have multiple profiles. We call it sub-accounts. And then one sub-account does not interfere with your other sub-accounts. So that's quite useful for users who are more risk averse. So how do we implement it? We use the move profile struct, where it records all of users' deposit and loan positions. And we also use a profile capability to perform access control. So we need access control because we don't want other people to borrow on behalf of ourselves. We only want ourselves to be able to borrow. But then for liquidation, it doesn't require this restriction. So anybody could come and liquidate our profiles when it has issues. And another thing that's worth mentioning is the customizable interest rate curve. So here's the definition of traditional lending market interest rate curve. And if you graph it, it's Aave, so it will have a two-piece linear curve. And similarly for Solend, it has three pieces linear curve. But what if we want a curvature that's defined by ourselves? It's very hard for existing lending protocol to actually define the curvature as they wish. But in our implementation, it's relatively straightforward thanks to moves. So how do we do it? So we use the special data structure back, which are heterogeneous collections, that for each type, it can contain types of, we can pass in different interest rate config. So that's unique when the interest rate config is different. So the bag will allow us to put in several different types. So what we can do is we have first a config type map that maps from a reserve address into a U8. So U8 is compound interest type. So as we define, it maps to 0. And then if we were to add new interest rate type, we just need to write, say, custom interest type, and it maps to other U8. And then once we know the exact type that the reserve interest needs to use, we can fetch it using the bag. We can use the compound interest config. And then as we show in the next slide, we will first get the compound interest type. And once we know its compound interest type, we can use bag borrow and address compound interest config. And we get out the compound interest config, and we call the relevant function get borrow rate yearly. And if we were to extend on top of it, we can just easily add a new if statement towards the end, and we define our own custom interest config. And we could have any implementation of get borrow rate yearly, and that will correspond to any other curvatures that we have. And finally, we have the asset agnostic flash loan. So that will allow us to borrow one asset and repay a different asset. So how do we implement it? We use a hot potato struct. And within the hot potato struct, we have the address of the user and also the profile address, as well as borrow amount. Once notice that it doesn't have a drop capabilities, so it will need to be explicitly passed in to other consumer functions. So we use a function called begin flash loan, and it will return a coin and a flash loan receipt. So this flash loan receipt needs to be passed in together with your repaid amount. And then we pass in the profile flash loan receipt into n flash loan together with the coin that is used to repay. And all of the security check is done in the n flash loan. Because we know the profiles, if user have already deposited certain assets into the profile, then as long as there's enough margin, user doesn't need to repay all of their debt because there's already enough margin within the existing profiles. Now let's take a look at the product in action. So I've talked about, now let's take a look at what the product looked like. If you want to switch to the link. So first, let's get ourselves on Sui, and then let's get ourselves on USDC and also Bitcoin. We're using Ethos wallet here. Yeah. So right now the DAppNet takes a bit of time to respond. DAppNet Bitcoin. Once we get the DAppNet Bitcoin, we can start to deposit certain assets. So create profiles creates a new sub-account. And notice on the top right corner, it writes what's your sub-account. So right now, we are on the main account. So we deposit 0.4 Sui, and it will show up on the right-hand side, where it shows all of the deposit and also all of your borrows as well. Now let's deposit some USDC. Wait for it to confirm. And borrow some Bitcoins. We automatically calculate what's your max borrow amount. And then also you can use half and max button to get the max borrow amount. Now let's create a new sub-account. We want to separate our risk. We can create a savings account like this. So once we confirm, create new account. So now we have a new account. So we can switch between main account and savings account. You can create any number of sub-accounts as you wish. And you can deposit only Bitcoin into the new savings account. And you don't need to perform any borrowing. You can switch between two accounts very easily. And then we also support internationalization. You can switch between English to Chinese, back and forth. And we also plan to add some new languages. Can you go back to the deck? And there are a few further implementation that we are currently working on, including a referral system that will allow a referrer to earn a protocol fees. And then we'll also integrate with DeepBook, the Sui order book. And we also plan to do a GMX-style fee sharing mechanism so that the user could share the protocol fees. And that's all from our presentation. Thank you. Feel free to reach out on Telegram and also on Twitter. I'm looking to talk to more projects within the Sui ecosystem and also potential liquidity providers. Thank you.